Hi there, welcome to 3x3 Systems. Here we have our system of equations. We're going to solve this. The immediate goal, first and foremost, change our 3x3 into a 2x2. The way that you're going to do that is through elimination. You need to eliminate, though, the same variable. So if I were to label these equations A, B, and C, they're also color-coded. If you're looking at combinations here, you could have the combination of equation A and B. You could also have a separate combination of A and C. And you could have a third one of B and C. You're going to need to use two of these three option sets right there and eliminate the same variable. That will then give us a 2x2 that we can use our 2x2 skills to go right ahead and solve. So if I'm looking at this, you really have a choice as to which variable you are going to eliminate. But to eliminate it, you would need to have opposite coefficients of the same variable. So for instance, if we wanted to eliminate x, if that is 4x, that would need to be a negative 4x or some variation of the multiples, but being opposite coefficients, so having a different sign there. My game plan here for this one will be to eliminate the variable of y. So first things first, let's take a look at equation A and then equation B. If we want to eliminate the y value, I see that as 3y. To eliminate a 3y, that would need to be a negative 3y. So to change this negative y into negative 3, I will multiply my first equation by 3. So my A, which is pink, multiplied by 3, would be 6x minus 3y minus 9z equals 3. And I'm going to put that together with my red equation B unchanged, 4x plus 3y plus 2z equals negative 4. And when we combine those two, we are going to get a new equation. What part of my 2x2? I see here 10x, those cancel, minus 7z equals negative 1. That is half of my 2x2. Let's work the other half of that 2x2 now. So I need to choose a second option. I have first chosen A and B. So now my second options would be A and C, and I need to get rid of y as well, or B and C to get rid of my y. Well, if I'm looking at A and C, I see a negative y and a positive 2y. That would be relatively easy to change. So let's deal with the options of A and C. If that is a positive 2y, that will need to be a negative 2y right there. So to change this to negative 2, I will multiply a by a value of 2. 2 times a, and let's see what we get here. I get 4x minus 2y minus 6z equals 2. And then my C equation, negative 3x plus 2y plus 5z equals negative 3. When we combine these two, let's see what happens. I get x minus z equals negative 1. Now this right here creates my 2x2, my new green and my new maroon. 10x minus 7z equals negative 1. X minus z equals negative 1. Well, choice is yours. You get to eliminate either variable that you would like. I'm going to go right ahead and eliminate my z variable. So if that is negative 7z, this would need to be a positive 7z. The way that that is going to happen is I will multiply this equation by negative 7. So my new green would be 10x minus 7z equals negative 1, actually the same green. And my new maroon, negative 7x plus 7z equals 7. We combine these, 3x equals 6, divide x equals 2. Well, there is one of the values of my solution. I now need to find a y, and I also need to find a z. So now you take this, plug in to the 2x2, the new 2x2 system that we have created there. It doesn't matter which one you use, choice is yours. So let's use the maroon one. X minus z equals -1. And what we are plugging in here is this value of 2. 2 minus z equals -1. I will subtract 2, negative z equals -3, z equals 3. There is the second part of my solution. Now we need to jump back up to one of my original equations. It does not matter which one we use, but the x and the z need to get plugged in here, and we can go right ahead and solve for my last variable. So let's just use the pink. 2x minus y minus 3z equals 1. Okay, let's slide this up so you can see it a little bit better. We are taking and subbing in my 2 and also my 3 value. 2 and 3 get plugged in, so it is 2 times x minus y minus 3 times z equals 1. And what we're subbing in here, x is 2, z is 3, then we just clean it up and see what we get. 4 and a -9, negative y minus 5 equals 1. I can add 6, y equals, I can add 5 to that, giving me negative y equals 6, y equals -6. There's the third value, and this is a lot of times, whoa, we ran out of room there. This is a lot of times represented in this fashion. But really, x equals 2, y equals -6, z equals 3. Either are or are appropriate by me. Now, let's take a look at something else, kind of some special cases that you need to be aware of. Let us use our imagination and say we have started with a 3x3, and from this 3x3, we have already changed it into a 2x2. And let's say our 2x2 comes out as 4x minus 8y equals -56, and x minus 2y equals -8. So like I said, use your imagination. We did everything we previously did, but now we're at the 2x2 step. So I'm looking at this, and really you kind of get to pick what you are going to do and pick the approach to this. Let's say you want to get rid of your x's. If we wanted to get rid of the x's, that is 4x, this would need to be -4x. So the way to change that, multiply bottom equation by -4. So my black, my original, unchanged, 4x minus 8y equals -56. And then my new modified pink, -4x plus 8y equals +32. So when we take a look at this and we use our elimination, well, those cancel. So you'd have 0 equals 30, 40, 50, so that's 18, and 6, -24. And I'm looking at that, and that is a false statement. That is not true. It is false. If you end up with a false statement as such, you will be saying no solution. There you go. And let us look at one more that is very, very, very similar to this, yet slightly different. So original system right here. So once again, we will use our imagination. We have started with a 3x3, and we have changed that into a 2x2. And here we are at the 2x2. 4y minus 3x equals 32 as one equation. Second equation, 8y minus 6x equals 64. So looking at this, you get to pick which variable you would like to eliminate. You can pick x's, you can pick y's, the choice is yours. If I see this is a 8y, this would need to be -8y. The way to change 4 to -8, multiply that thing by -2. So my new modified blue equation, -8y plus 6x equals negative 64. My red, 8y minus 6x equals 64. Let's do the elimination, clean it up. Gone, gone. So I get 0 equals 0. That statement right there is true. If you end up with a true statement, there will be an infinite number of solutions. You end up with a false statement, no solution. You end up with a true statement, you have an infinite number. I hope that helps. See you around.